My name is Bob Kaplan, and today I'm going to talk to you about control systems. Specifically, we're going to talk about methods of control and damping. This is Jimmy Jetpack, and he wants to hover at a specific height of 1. To do that, he's going to need to lift off of the ground, reach the proper height, and then stay at that height. This is where control systems come in. Control systems are used to tell Jimmy's jetpack what direction to thrust and for how long. The system is given a target and then sends instructions to the jetpack to reach that target. There are a few different methods we can use to do this. The first one we're going to look at is called bang bang control. Bang bang control only allows Jimmy two different modes for his jetpack: full throttle up and full throttle down. When Jimmy takes off, he's going to follow a path that looks like this. Because he can only control the direction of the thrust and not the magnitude, he has to switch back and forth very rapidly to try and stay near where he wants to be. And even then, he can't quite stay there. We're going to switch Jimmy to proportional derivative, or PD control. Jimmy's path using PD control initially looks pretty similar to what we saw from bang bang control. The difference is, with PD control, we can use damping to control Jimmy's path. You can think of damping like a shock absorber that slows our rate of ascent to help keep us on target. Let's see what it looks like with some damping. Oh no, that's way too much damping. Jimmy isn't getting to the height he needs fast enough. This system is what we call overdamped. Let's turn the damping down and see what happens. Now we have a new problem. Jimmy overshot the target height by a lot, and we don't want him to bump his head on the ceiling. This system is what we call underdamped. We need to find just the right value for our damping so Jimmy reaches the right height quickly but doesn't overshoot and go too high. That looks perfect. We got to the right height quickly and we didn't overshoot at all. This system is what we call critically damped. There's a problem though. This whole time, we've been pretending that there aren't any forces acting on Jimmy besides the thrust from his jetpack. But what about gravity? If we add a persistent downward force to represent gravity and try again with the same settings, what happens? With the addition of that constant downward force, Jimmy isn't able to stay at the right height anymore. We fix this by switching to proportional integral derivative control, or PID. PID control adds a third parameter which helps us to compensate for the external forces acting on Jimmy. Let's see what happens now. Perfect! With the addition of the integral gain, we're able to compensate for gravity and get Jimmy back on target. The system is back to being critically damped, just like we want. I was inspired to do this project after seeing this video of testing of the Lockheed MKV and wondering what the control system was like. Thank you for listening.